Okay, today we're going to start Chapter 4, and Chapter 4 is all about the differences between linear and nonlinear functions. But before we start looking at the differences between those two types of functions, we're going to start talking about how we can analyze graphs. And more specifically, we're going to talk about how we can use graphs to relate quantities or different variables. So we use graphs to visually represent a relationship between two variable quantities as they both change. And what we're going to look at is discuss what's happening in the graph or the visual that we're given, or creating a visual based on a given situation. So if we take a look at problem 1, the graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? And describe how the variables are related at various points on the graph. Now remember, variables are amounts that change. So the things that are changing in this particular situation is volume and time. So our two variables are going to be time and volume. Time is considered the independent variable, and volume is considered the dependent variable. Volume is the dependent variable because the volume of air in the balloon depends on how much time we've been blowing air into it. Now, if we have to describe how the variables are related, as you can tell, over time, as the time is increasing, the volume is also increasing. However, it's not increasing at a steady amount. What's happening is the volume increases, and then there's a pause for a little bit. And then the volume increases, there's a pause again. And this continues to happen until all of a sudden the volume goes down. So what's happening in this situation is over time, somebody's blowing air into the balloon. When this happens, the volume of the balloon increases. The volume then stays the same when the person takes a breath. And this continues until the balloon pops. So what you have to do is you have to describe exactly what's happening in these situations. You would have to describe why the volume is increasing and why it's also staying the same at certain points in time. We know that the balloon pops because at the very end of the graph, the volume goes down to 0. So let's take a look at the next one. What are the variables in each graph? And describe how the variables are related at various points on the graph. So if we take a look at this diagram, we are looking at the June cell phone cost. So I know that a lot of you don't pay your own cell phone bills, but if we take a look at the variables, the things that are changing, we have the number of minutes in the call and the cost of the actual call. So our two variables are going to be the minutes of the calls and the cost, the cell phone cost. So what used to happen is, or sometimes maybe still does, depending on the type of phone you have, you'll have to pay based on the number of calls you make. Now in this situation, it looks like the cost is staying constant. The cost isn't changing until we hit a certain point. So this whole time here, the cost is staying the same. And then all of a sudden at a certain point, the cost starts to increase. So what we're going to say when we describe the situation is we're going to say that the cost remains the same for a certain number of minutes. However, after the certain number of minutes is reached, the cost increases at a constant rate. Okay, let's take a look at our next scenario. Sometimes we're not just given pictures, sometimes we're given graphs and tables. So tables and graphs can both show relationships between variables. Data from a table are often displayed using a graph to visually represent the relationship. So now what we're going to do is we're going to compare a table to a given graph. In problem 2, it says a band allows fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table below? So what we're going to do is we're going to compare each one of these graphs to the information in the table. If you look at our number of days is increasing steadily. So each day we're going up by 1. So you want to make sure, if you look at each one of these graphs, that the days are increasing. And it looks like in this graph in A, days are increasing and the total downloads are increasing. In B, as days are increasing, the total downloads are still increasing. In C, as the days are increasing, the downloads also increase, but not at so fast of a pace. And in part D, the days are increasing, but the downloads are actually decreasing. Well, if you look at our table, our downloads are not actually decreasing. Our downloads are increasing. So what we're going to do is we're going to eliminate option D. Now, in order to figure out whether it's A, B, or C, we're going to have to take a look at how these downloads are changing. So if we look at A shows a linear relationship. It shows that the number of downloads is going up at a constant rate. In B, it shows that our downloads are increasing pretty quickly as the days are going by. And in C, again, our downloads are increasing, but not so much at the very end. And if you look at the table, during day 3 and day 4, those downloads are going up quite a bit. They're going up pretty fast. So we're going to eliminate option C as well, because option C shows a slower growth. Now, to figure out whether there's a constant rate of change, as in A, or a fast rate of change, as in B, we're going to take a look at how the downloads are changing. So what I'm going to do is I'm going to look at the difference between 346 and 1011. And I find that those downloads go up by 665. Then I take a look at the next 2 days, and I look at the difference between 3455 and 1011, and I notice that that goes up by 2,441 downloads. And then for the next set of days, to go from 3,455 to 10,426, those downloads increase by $6,971. So there's not a constant rate of change here between the numbers of downloads, so it's not going to be option A either. Option B is the correct answer. Okay, let's try this one. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So again, we're going to look at what the table shows versus what the graphs are showing. My two variables are the number of uses and the amount of sunscreen. So the number of uses is going up, but the amount of sunscreen is actually coming down. All three of these graphs show that relationship. So I'm going to first take a look at what's happening with my number of uses. The days are each increasing by 1. And then if I look at the sunscreen decreases, but it's decreasing very, very slowly. So what I'm going to do is I'm going to eliminate option B, because option B shows that this sunscreen over the course of a couple days decreases quite fast. Now, what I have to do is look at the differences between A and C. A shows the sunscreen decreasing at a constant rate, but C also shows the sunscreen decreasing at a constant rate. And if we look at the differences between 5 and 4.8, I'm going down by 0.2 ounces each time. But this graph in A shows that I'm going all the way down to 0 sunscreen. But in the number of uses, after 3 uses, we don't see that it goes down to 0. We see that it goes down to 4.4. So option C is going to be the correct answer for this one. Okay, now let's change the situation, and this time I'm going to give you a situation, and you're going to sketch the graph of the situation. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. Sketch a graph that would represent the height of the rocket during the course of its flight and label each section. So we want to graph the height of the rocket during its flight. So we have to figure out what our two variables are going to be. Well, I definitely know I'm going to want to deal with the height of the rocket, but the height of that rocket is going to depend on the time that has gone by. So height is going to be on my y-axis, and time is going to be on my x-axis. Now, if we think about setting a rocket off, usually what we do, I would hope that we have it on the ground. I mean, you don't want to be holding the rocket. Now, we could have it on a table, so we might start our height a little bit lower. But typically what happens when we start a rocket is the rocket starts on the ground. So that's where I'm going to start my flight, right at the origin. And it tells me that the rocket rises quickly. So I want the height of this rocket to go up pretty darn fast. And then it starts to slow to a stop. But what happens is, after its fuel burns out, it's going to fall quickly. So it's going to go back to the ground real quick, but then its parachute opens. So when its parachute opens, it starts to fall slowly back down to the earth. So that's basically the path that the rocket is taking over time with respect to height. Now, they also want me to label each section, so I'm going to have to talk about what's happening at these certain times. So here, as the rocket is increasing, this is where it's going to rise quickly. So this section here is where we're rising quickly. So we're going to label that section Rise Quickly. And then what happens up here is the fuel starts to burn out. So the fuel is going to burn out right there. And then it says it falls quickly. That's what's happening at that point, when we're going back down very quickly. And then the next part is the parachute opens. So the parachute is going to open right where the rocket starts to fall quickly and then starts to fall slowly. So right at that little crook in the rocket's path is where we're going to say that the parachute opens. And then finally, the rocket is going to fall slowly back to the earth. So you want to be real careful to make sure you're following all the directions, because typically when we have to graph a situation that we're given, you're going to have to graph and label your section. So you want to make sure that you do that. Okay, now you're going to start to work on your homework. You're going to work on numbers 5 through 10 on page 237, and then 15, 18A, and 20.